So we walk through number one. You're going to do it the same way. Now, the x-intercept, you can't find the x-intercept algebraically yet because we didn't do logs. But if you looked in your calculator, you could find a 0. I'm not concerned about the x-intercept. I'm concerned about the y-intercept. I want a domain, a range, a y-intercept. I want your asymptote, and I want your transformations. So make sure I get those. Now the second one, here's your parent graph, 2 to the x. Put that in your calculator. And in the second one, just put the negative in front. What does this negative do? Reflect over the x-axis. So my original one will now reflect and will be this one. There's your reflection. And then this will go up 3 units, a vertical shift up 3 units. Then put the second part in. If you do one part at a time in your calculator, watch what happens. So I'm going to do 2 to the x, and then I'm just going to do negative 2 raised to the x. I want to see what is that doing for me. And I'm going to graph this, just to see what the negative does. So I graph it, and I see my reflection. Okay, it's just a reflection. Then I shift it up 3. You could go to a third one, or you can then put it in here. And then shift it up 3. That's what your vertical shift is going to do. If it helps, you can put your asymptote in here. It is a horizontal line. Watch. Your y equals was your original 1. Y equals 0. That was your original 1. So if you just graphed your parent graph at y equals 0, you would see it. If you moved it up 3 after you reflected it, you could put in your y equals 3 in here. Do you see the asymptote now, how it moved? Anything that affects the y affects your asymptote and your range. And because it's a horizontal line, you can put that in your calculator as well. And even though your calculator stops, it's traveling along that line. Your x-intercept, plug in a 0 for x. That's the easiest way. Anything to the 0 power is 1. So that gives you a negative 1 plus 3. Or if you dropped it to negative 1, then added 3, there's your 2. But I should see all of this. I find the sketch is very helpful. I like to sketch one step at a time. I know students go right to the chase and put it in the calculator and give me the final sketch. And that's fine, but you don't see the individual transformations. So if you sketch one part at a time, I think it's even easier than putting it in your calculator. Okay, parent graph, 4 to the x. What is this plus 3 doing? What's that plus 3 do when it's next to the x? Horizontal shift which way? Left, the opposite way. Now that would affect my domain. However, my domain is all real numbers, so there's no effect on that one. So your domain still stays the same. You shifted left, 3, horizontal shift. Make sure you use the right words. And then a vertical shift down 2. So from there, you could change your, if you wanted to, take your 0, 1, shift it to the left, 3. That's moving your x value to negative 3, 0. Then it's moving that down to negative 3, negative 1. That's also helpful when you put that in your calculator, that you could look at your table and see that. I think it's even more helpful to see that point in your table. Your asymptote dropped 2 because it's only affected by a vertical shift. Your intercept, plug in the x of 0. Your intercept is pretty far up there. Okay? Questions? Alright, okay, these aren't so bad. They're pretty simple. You just have to do them. Now, the next two, I apologize. Somehow it is writing over it, yet when I print the page out, it prints out fine. So I'm really not sure why this is doing this. But there's two ways you can actually do this. You can do this one with the negative x plus 1, or if you wanted to, you could factor out the negative and put it in front. You could do it either way. Either way, you'll get the same result. If you did it with the negative x, remember the negative x plus 1, you're going to reflect because it's next to the x. You're going to reflect in your y-axis, and you're going to do a horizontal shift left 1. That's what it says here somewhere. Right here. Reflection over the y-axis and a horizontal shift left 1. If you factored it out, then you're just going to do a horizontal shift to the right 1 and then reflect over the y-axis after that. It'll work out the same. And then lastly, you'll do your vertical shift. It's a horizontal shift. It depends which way you go. If you leave it just like you read this, then it's to the left 1. If you reflect it first and then shift it, like this is where the reflection comes in at a different time. But it turns out the same exact way. And then you vertical shift it up 1 at the end. So there's two ways to do this one. The same with the next one. Where it says 2 minus x, it looks better if you do this. Because then you can see a reflection, and then you can see your horizontal movement the opposite way. And again, you can factor out a negative 1 out of that one. That one was probably a little bit more work. I think this says plus 4 underneath it. For some odd reason, it prints out fine, but it doesn't come out fine here. I don't know what happened to it. So if you go with the x minus 2, you've got a horizontal shift to the right 2, and a reflection over the y-axis. The reflection came first, and then the shift. If you do it the other way, you get the reflection and then the shift at the end. And either way, you're going to do a vertical shift up 4. Keep track of your asymptote in this one. The only thing that affects your asymptote is what? What's the only thing that's going to affect it in this last one? Is the vertical shift. Is the vertical shift up 4. You've got another reflection here over the x-axis. So be careful, you've got 2 reflections in this one. So it's going to end up a little bit differently than it started. I'm not going to give you anything that involved, because that one's a pretty tough one. But tonight, what I want you to do tonight, guys, is